Welcome back to GIS Analysis at the University of Alaska Fairbanks. Last week we dealt with LiDAR rasters, which are typically fine spatial resolution of 1 meter pixels or even smaller. This week we're going to delineate watersheds using elevation rasters that have a much larger area. So typically the pixel size could be from 30 meters on up to the order of kilometers. And what we're going to do in this sequence of video sessions is delineate the watershed of the Yukon River. So the first thing you need to do is go to the website earthexplorer.usgs.gov and register with that website. And once you're registered, if you go to data sets, what we want to do is go to digital elevation. So if you scroll down, here's digital elevation. And we'll download a data set from this GMTED 2000. So we'll check that on, and if I check on the information icon, it'll describe that data set. So this is a global raster data set of elevation rasters, so we can use it for any land surface in the world. And we're going to download 2 tiles for the area of the Yukon River in Alaska and Canada. So if you scroll to search criteria, we can specify the area we're interested in. We can zoom in on the area of Alaska and Western Canada, and then use map. And then if we zoom out, here's the area in our map. And then if we click on data sets, we've already specified what we want, so we can click on results. So then it finds the tiles that cover the area. Here's a tile that covers the area that we're interested in. This tile, north 50, 150 west, we want that tile. And here's the second tile we want, north 50, 180 west. So download these 2 tiles. And since we're interested in a large area, we're going to download a tile where the elevation is estimated every 30 seconds. So we'll download the 30 arcsecond tile. And I'll download this tile into Yukon Watershed Elevation folder in my NRM 435 folder. And we download our second tile, 50 West 180. So it's actually north 50, west 180. And also 30 seconds. So the next step is to unzip these 2 zip files, and that will expose our elevation rasters that we can use in ArcMap. So I'll right mouse click and I'll extract all. And then that was for north 50, 180 west. So then the other one is north 50, west 150, and extract all. So in ArcMap, let's assign our home folder to be the same folder we downloaded the elevation rasters to. So if we file, save, and then browse to that folder, and we'll go in that folder, and then we can name our map document. So now we've got our home folder, and inside our home folder we've got our MXD file, and we've got our rasters. So these rasters are the mean elevation, the median elevation, the minimum elevation, the standard deviation of elevation, etc. What we're going to work with is the mean elevation inside every pixel. So here we have the western half of our study area, and then the mean elevation for the other raster. So then let's zoom to full extent. So then we have the area we need of Alaska and Western Canada. And you'll notice that we have values from sea level to 910 in one raster, sea level to 440 meters in the other raster, So that's why the contrast is going to be different. Next step will be to stitch together these two rasters. And in order to do that, we're going to use a geoprocessing tool, Mosaic to New Raster. Mosaic are two mean elevation rasters, and our output location is our home folder, so we'll add that as our output location. And then the name of our raster, let's call it elevation, and it's going to be in longitude and latitude, which is a geographic coordinate system, so GCS.TIFF. And then the pixel type, we have to look at the raster properties to determine the pixel type. So our pixel type in this example is under source. It's a signed integer 16-bit. So pixel type is 16-bit signed integer. And then the number of bands is how many values are there inside every pixel. In this case, there's one elevation value inside every pixel. And then OK, we'll create our output raster, which will be elevation GCS.TIFF. Here's our output raster, and it now ranges from sea level to 6,035 meters. And everything is still in longitude and latitude, so the next step will be to project this raster into square pixels that are in meters. So to do that, we'll use the Project Raster tool. So we're going to take our elevation raster where the pixels are not square, they're in longitude and latitude, and we'll output them to our home folder, and it will be an elevation raster where there's square pixels and they're in meters. Actually, let's do it. It'll be 1 kilometer pixels, so we'll give it 1 km. So then the output coordinate system, if you go to projected, continental, North American, we're going to use the Alaska-Albers coordinate system, which is in meters. And then the final thing we have to do, if you scroll down, we as a user specify what is the output pixel size. So we want our pixels to be square and 1 kilometer, which would be 1,000 meters. And then what we want to do is our resampling method, don't pick the nearest value, take the weighted average of the 4 nearest values. So that's bilinear interpolation. We'll have weighted value of the 4 nearest pixels, and it will be output to elevation 1 kilometer.TIFF, because as a user, we specified we want square pixels that are 1,000 meters by 1,000 meters. So then you notice, since we use bilinear interpolation to get the weighted average of the 4 nearest pixels, our high now is slightly changed, but that's fine. So let's remove our raster that's in longitude and latitude, and then let's assign for our data frame the same coordinate system as our elevation raster that's in kilometers. So then if we go to properties, for our data frame coordinate system, we'll assign the same as our layer, which is the Alaska-Albers coordinate system. So now we have our elevation raster where everything's in square pixels, and if we look at the raster properties, they're 1,000 meters by 1,000 meter pixels. So in the next video session, we'll use this raster that's now in square pixels that are in meters to create hillshades, contours, and things like that.